Hello, my name is Moqi and I'm going to make presentation for the first part of this project. Here is an overview of our project, and we implemented the following functions. The step 1 is autocomplete. We firstly transfer all the input letters into lowercase to make it case insensitivity, and then iterate all nodes to check if they match with the input. This picture is a screenshot that when we enter CH, what will come out. For the step 2, here is a screenshot that when we enter refs, the longitude and latitude it returns. And to calculate the eddy distance D, we use the dynamic programming. The running time complexity is OMN, and let's define Dij to be the eddy distance between AI and Bj. And it turns out that we could compute Dij after knowing these three status. And there are two different situations, and the formula to calculate the Dij according to these situations are listed here. And when the eddy distance is 1, we can find a closest name. Here is a screenshot that when we enter refs and what will come out. And for step 3, to get all categories without duplicates, we iterate all items and put them into a set. Here is a screenshot of the output of all our location categories. And for step 4, we're using a function from step 3 to get all categories in a vector. Then we iterate all items in the vector and return those which have the same category as the input. When we enter bank, here is the output of this screenshot. And for step 5, we first use a function to check if the regular expression is invalid. If not, we iterate all nodes and use regex match function to find the result. When we enter this input, here are all the locations, longitude and latitude that match with it.
Hello, I'm Junyu Huang. I'm going to introduce the remaining parts of this project. In step 6, we are calculating the shortest path between two places. Here, we are implementing two algorithms to get the shortest distance and path. The first one is Dasher, and the second one is Bellman flow. Here is the shortest distance and path from refs to target, which is quite similar with that in Google Map. As for the runtime comparison of these two algorithms, we can clearly see that Dasher runs much more faster than Bellman flow. But Dasher cannot handle negative edges, while Bellman flow can report the negative cycles and handle negative edges. Step 7, cycle detection. This function is used to detect if a cycle exists in the subgraph. Here we need to input two latitudes and longitudes to get the results. Here are two examples. The first one is no cycle, and the second one, there exists a cycle in the subgraph. Step 8, topological sort. The basic algorithm we use in topological sort is quite similar to that used in the cycle detection. They are both based on DFS. The only difference is that in cycle detection, we are handling an undirected graph, while in topological sort, we are handling a directed graph. To get the topological sort, we need to input the names of locations and the dependence of them. Here is a result of it. Step 9, Turing salesman problem. Here we are using three methods to implement this: brute force, early backtracking, and 2-opt. Here is a result when running the program. This one is the result from brute force. And the early backtracking. The third one is 2-opt. From these two tables, we can see the runtime for brute force is quite slow, which is n factorial. That's because in brute force, we need to permutate all the possibilities to get the shortest path. And for early backtracking, although we can skip the cases where the current distance is larger than the minimum distance, which could speed up the process, if we consider the worst case, the runtime is still n factorial, the same as the brute force. That's the reason why those two methods would be timeout when the number of inputs gets larger. But for 2-opt, the runtime for it is n squared, which is super fast, and we can even get a result of 50 inputs before timeout. However, it may not give an optimal solution for larger input. Step 10, find nearby. In this function, we need to input attribute, location, radius, and members. Then we can get output of a list of locations with the same attribute within that radius we input. Here's a result. That's all. Thank you.
Thank you.